In the previous lessons, we've aligned ourselves to the mindset of a mechanical engineering consultant. We've looked at the expectations that your managers have of you, and we've seen the impact of your work in the business context. Now we get to the hands-on, day-to-day, actual actions. At a high level, you will be a successful engineer if you execute project management successfully on the projects assigned to you. Let's look at what that entails. We will look at the project plan, tasks and methods, resource allocation, risks, and important and urgent tasks. Depending on the policies of the company you work for, you may be provided with project proposals drawn up by seniors, or you may have to draw these up for yourself. First and foremost, the thing that determines your day-to-day is the project proposal. If it is accepted by the client, it becomes the project plan. This plan notes the stakeholders in the project. It includes the problem statement, as received from the client and restated by the company. It includes the scope of work, which is a whole section that we'll unpack in a future lesson. It includes the risks that are associated with the different tasks discussed in the scope of work. The resources allocated to each phase in the scope of work is explicitly noted, with how it will be utilized and the cost associated with the resources. It may include exclusions and payment details as well, but most importantly, it is an all-encompassing document that is created and agreed upon at the outset of the project. Any additions or changes to the work detailed in this document will need new terms of acceptance. This is your North Star as an engineer. The project plan is where you find the answers to all the possible questions you might have at the outset of the project. If there are more questions than answers, you are either looking at a poorly drafted project plan or venturing into project execution land. The first, most obvious question that you will need to ask is, what do I need to do? This will be detailed in the scope of work section. The scope of work has every task listed that is required to address every requirement of the project. Let's go through an example of a scope of work of a project where a gear failed in a gearbox, and the deliverable is a root cause of failure analysis. It may start off with a review of the client's applied documentation and move to detailing a limited mission profile of the gear in question. This limited mission profile sets out the parameters that you will use when analyzing the loading that was experienced by the gear. This analysis may be one step, hand calculations, or multiple steps with a finite element analysis simulation. You may complete an inspection on the failed part if it is still available. Then you will compare your findings with regulatory requirements or standards information and draw up a diagram noting the possible causes of failure and detailing the specific failure mechanisms. Each of these phases will have some deadline to them, some resource that is used, and some methodology to be followed. When you create your task list for the project, make sure to only draw from your specific project scope of work. I've mentioned resource allocation a few times already. Here, I go into details. Every phase of the project requires that some resource is utilized. Your time as the project engineer is the main resource. The hours that you spend on task are limited, which are detailed in the project plan. But you may need equipment like a camera, a laptop, testing equipment to complete some tasks, or software licenses like for CAD, FEA, CFD to be able to provide the required value to the client. Each and every one of these resources has a rate associated with them and time that increases the cost. You should know which resources are to be used in the project and ensure that you stay within the time limits allocated for these resource allocations. For instance, using SolidWorks for longer than the project phase stipulates may cause a backlog in other project progression, which causes delays, which are costly. Explicitly, the costs associated with a project backlog is quantified in terms of money. Maybe the client must spend more money on the project. Maybe the company that you work at will not receive payment for the resource usage. And maybe, in the worst case scenario, the company loses the client and receives a hit on their reputation. Your resource usage, therefore, is very important consideration. Each project phase has risks associated with it. The client may not provide integral information. You may need to make assumptions, which could turn out to be wrong. You may not know the analysis methods to apply to solve the problem. You may not have experience on the simulation software. The information you've gathered may result in determining two mutually exclusive root causes of failure. The power could die and corrupt your simulation that's been running for 7 days and needed 10 minutes to finish. Load shedding in South Africa is a thing. And yes, it has happened before. You could get in a car crash on the way to or from a client site. You might step in a pile of lime that was not marked or cautioned. You may slip and fall walking in a hallway of a subcontractor building while 6 months pregnant. My baby was 100% fine. At the project proposal stage, you need to come up with at least one risk to mention at every stage of the project. At project execution stage, you will need to come up with either actions to take if the risk does occur or actions to take to prevent the occurrence of the risk. One main risk that you may include in your thought experiments may be to note your lack of experience in executing certain tasks, though you think that you should be able to execute these tasks already. But a mitigating action would include something that you've been doing since the first lesson, which is planning ways to improve your standing. The fact that risks are intrinsic in any work that you do is a pain, but clear communication with your project manager and technical lead, and if applicable, the client, about the risks and whether they are mitigated or occurring is vital in project success. A quick actionable tip here is to identify risks at the project planning stage and introduce mitigations for all risks at the project execution stage. Now that you have tasks extracted from the project proposal and risks extracted from the project plan, you can begin to prioritize the tasks based on importance and urgency. You would have heard of this concept. I will gloss over it. A task may be important or not important. It may be urgent or not urgent. You might scale a task on these two axes and find intersections. At the combination of project deliverable timelines, all the project deadlines always occur exactly at the same moment and exactly at the least opportune moment. You will prioritize the urgent and important tasks, and then the urgent non-important tasks, and then the non-urgent important tasks, and finally you will think twice about completing the non-urgent non-important tasks. I want to get to the addition of risk management on this step. Each task might have a risk associated with it. Maybe the risk is that you're not trained, or have forgotten your training on a specific analysis method. You can't remember how to specify a specific bearing with all the bells and whistles that go into the complete specification. This is a risk. The mitigation steps might be that you will watch YouTube videos on it, read your class notes if you still have them, or ask your senior about the company SOPs regarding these specifications. Regardless of the mitigating actions that you have detailed, the planned time for the execution is definitely increased. This sets the completion of the task up a notch in terms of urgency. Start sooner so that when you get to having to execute on crunch time, you've already done the pre-work or the rework. Prioritization is key to making sure you focus on what truly drives the project success and minimizes risk. Managing your own project makes the project manager's task possible. You are operating as the resource that they allocated to the project. We've introduced the project proposal and project plan, discussed how you would use it to create a task list, and identified the resources needed for the completion of the tasks. Then we discussed how you would think about risks associated with your task and how you can prioritize well to deliver the most impactful value in the most strategic way. Now you get to apply this knowledge in the activity for the week. I've created a template that you can fill in for all your projects going forward. That will align you with the strategies set out in this lesson. You can use the worksheet in the completion of the activity. In the activity for this lesson, you will develop a project management plan for an engineering project that you're working on, or a hypothetical one if you're not on something currently. You can find the worksheet template with the necessary information. By the end, you should feel confident in applying these principles and techniques in real-world engineering projects. In the next lesson, we start looking into project planning.